Yes guys, it's Jad from Jad Maths here, and I'm going to do this question from 1994, step 1, question 8. So we're going to start off by doing this first integral. So we have the integral from 0 to pi over 4 of ln 1 plus tan theta d theta, right? And we're told to use this substitution. So we're going to get theta equals pi over 4 minus phi. So d theta is going to be negative d phi. And then changing our bounds, we're going to get phi 1 is going to be pi over 4 minus 0, which is going to be pi over 4. And phi 2 is going to be pi over 4 minus pi over 4, which is going to give us 0. So rewriting our integral, we get the integral between pi over 4 and 0 of ln 1 plus tan, pi over 4 minus phi d phi, and also there's a negative over here. So we can bring this negative out of the integral, and then also because we have a negative here, we just swap the bounds. So you can rewrite this as go from 0 to pi over 4 ln 1 plus tan pi over 4 minus phi d phi. Now we're going to use the addition formula for tan on this. So recall that tan a minus b is going to be tan a minus tan b over 1 plus tan a tan b. So recall that tan pi over 4 is just 1. So rewriting our integral using that, we get integral from 0 to pi over 4 of ln 1 plus tan phi over 1 plus tan phi. Is that? Yeah. No, it's 1 minus tan phi. D phi. And then combining these into a single fraction, we get the integral from 0 to pi over 4 ln 1 plus, 1 plus tan phi or 1 plus tan phi plus 1 minus tan phi plus tan phi d phi. And then so notice that these two tan phi's just cancel out, so we get I equals the integral from 0 to pi over 4 of ln 1 over 1 plus tan phi d phi. So now we're going to use our log laws to split this, so we get the integral from 0 to pi over 4 ln, oh yeah, no, this is actually supposed to be a 2, not a 1, my bad. Ln 2 minus ln 1 plus tan phi d phi, and then we can split the integral 0 to pi over 4 ln 2 d phi minus the integral from 0 to pi over 4 ln 1 plus tan phi. So notice here that this is literally just our original integral, but with a different variable. So we're just going to add this to the other side. So we're going to say that I equals the integral from 0 to pi over 4 of ln 2 d phi minus I. Yeah. So then add I to the other side, we get 2I equals the integral from 0 to pi over 4 of ln 2. Yeah, and then so we get 2I equals phi ln 2 between 0 and pi over 4, so we get 2I equals pi ln 2 over 4, so I equals pi ln 2 over 8, which is what they were asking from us in the question. Now we're going to do the second integral they asked us to do in the question, which is evaluate that. So our integral is is the integral from 0 to 1 of ln 1 plus x over plus x squared dx. Now, in the last question, we did the integral of 1 plus tan x, but we have an x here, so we're going to make a substitution. We're going to say x equals tan u, so dx equals sec squared u du, and remember that's just 1 plus tan squared u du, and then remember tan u is just x, so that's just going to be 1 plus x squared du, and for our bounds, I'm going to say u1 is tan 0, which is 0, then u2 is, it's arctan 0, and then u2 is going to be arctan 1, which is going to be pi over 4. So, rewriting our integral, we get I equals integral from 0 to pi over 4 of ln 1 plus x over, no, not 1 plus x, it's 1 plus tan x, no, tan u even, over 1 plus x squared times 1 plus x squared du. Notice these just cancel out, so yeah, the integral from 0 to pi over 4 of ln 1 plus tan x, no, tan u du, and that is literally what the last question was. So we know the answer is just going to be, what was it again, pi over 8 ln 2. Right, so now we're going to do the third integral, which is this. So, using our laws of logs, I'm going to separate what we have here into the integral from 0 to pi over 2 of ln 1 plus sine x minus ln 1 plus cos x dx. Now I'm going to write this as two separate integrals. Now, similar to what we did in the first part, I'm going to do a change of variable on this one. So we're going to let x equal to pi over 2 minus u. So dx equals minus du. And our bounds are just going to go, what was it? So u1 is going to be pi over 2 minus 0, which is going to be pi over 2, and then u2 is going to be 2 minus pi over 2, which is going to be 0. So, right, so now we're going to rewrite our integral as the integral of 0 to pi over 2 of ln 1 plus sine x dx. I just realized up here there should be a 1. Yeah, there we go. Minus the integral from pi over 2 to 0 of ln 1 plus cos pi over 2 minus u du, and then we're just going to swap the bounds again, so we get equals 0 to pi over 2 ln 1 plus sine x dx minus the integral from 0 to pi over 2 of ln 1 plus, now notice cos pi over 2 minus u is just the same as sine u, because they're just like translated along from pi over 2 from each other, if that makes sense. So sine pi over 2 minus x equals cos x, and then vice versa. So I'm going to write that as sine u du. Now notice these two are literally exactly the same thing, like they're going to give you the same value even though the variable is different, so we just get I equals 0. So the value of our integral is just 0.